Hello everyone and welcome to our educational presentation. My name is Paul Arsov and I'm the founder of the Decentralized Web project. The topic of our educational event today is pushing reset on what we expect from AI. AI is viewed either as a panacea for all that ails us, or a dangerous threat to be approached with caution. Those are two extreme messages often heard about historically transformative technologies. The truth likely lies somewhere between the two. So I'm going to talk and mention recent 2024 MIT Sloan symposium. And at this symposium, AI was the dominant theme, with a number of keynotes and panels devoted to the topic. In addition, a pre-event program included a number of informal roundtable discussions, such as the legal risks in AI development, AI as a driver for productivity, and human roles in AI augmented workplaces. One highlight was the closing keynote, what works and doesn't work with AI, where the MIT professor Rodney Brooks offered some guidelines to sort the hype from reality. Professor Brooks was director of the MIT AI Lab from 1997 to 2003 and was then the founding director of the MIT's Computer Science and Artificial Intelligence Lab until 2007. A robotics entrepreneur, he has founded a number of companies, including iRobot, Rethink Robotics, and Robust AI. Brooks presented his three laws of artificial intelligence that put AI in perspective as follows. When an AI system performs a task, human observers immediately estimate its general competence in areas that seem related. Usually, that estimate is wildly inflated. The second law the professor defined is most successful AI deployments have a human somewhere in the loop, perhaps the person they're helping, and their intelligence smooths the edges. The third law is without carefully boxing in how an AI system is deployed, there are always a very long tail of special cases that can take decades to discover and fix. Professor Brooks reminded us that AI has been an academic discipline since the 1950s, when the field's founders believed that just about every aspect of the human intelligence could in principle be precisely expressed as software and executed in increasingly powerful computers. Into the 1980s, leading AI researchers were convinced that AI systems capable of human-like cognitive capabilities could be developed within a generation, and obtained government funding to implement their visions. Eventually, it became clear that all these various projects had grossly underestimated the difficulties in developing machines exhibiting human-like intelligence. Because you cannot express in software cognitive capabilities like language, thinking, and reasoning. After years of unfulfilled promises and hype, these ambitious AI approaches were abandoned, and the so-called AI winter of reduced interest and funding set in. AI was reborn in the 1990s. Instead of trying to program human-like intelligence, the field embraced a statistical approach based on analyzing patterns in vast amount of data with sophisticated algorithms and high-performance supercomputers. AI researchers discovered that such an information-based approach produced something akin to intelligence. Moreover, unlike the earlier programming-based projects, the statistical approaches scaled very nicely. The more information you have, the more sophisticated the algorithms, the more powerful the supercomputers, the better the results. Over the next few decades, AI achieved some very important milestones, including Deep Blue win over chess grandmaster Garry Kasparov in 1997 six-game match. IBM Watson's 2011 win of the Jeopardy challenge against the two best human Jeopardy players, and AlphaGo unexpected win in 2016 over Lee Sedol, one of the world's top Go players. In addition, a number of entrants successfully completed the 2007 DARPA Grand Challenge for self-driving vehicles in an urban environment, and 2012 DARPA Robotics Challenge for the use of robots in disaster or emergency response scenario. After these and other milestones, AI appeared to be just on the verge of changing everything. But is it? Since 2017, it has been posting prediction scorecard at the beginning of each year, where like Professor Brooks compares the predictions for future milestones in robotics, AI, and machine learning, in self-driving cars, and in human space travel. He says, I made my predictions because at the time, just like now, I saw an immense amount of hype about these topics, and the press and public were drawing conclusions about all sorts of things they feared. For example, truck driving jobs and all manual labor of humans about to disappear. They also predicted safer roads or safe heaven for humans on Mars, and other imminent so-called advances. The predictions with dates attached to them were meant to slow down these expectations and inject some level of reality into what we are seeing as irrational exuberance. So why have so many AI predictions been so wrong? Professor Brooks, who apparently favors lists, believes the answer in what he called the 7 deadly sins of predicting the future of AI. And in 2017 essay, he describes these 7 sins. The first one is overestimating and underestimating. So it brings back to what becomes known as Amara's law. We tend to overestimate the effect of technology in the short term and underestimate the effect in long term. Artificial intelligence has the distinction of having been the shiny new thing and being overestimated again and again in the 1960s, in the 1980s, and we believe right now. Indistinguishable from magic. It is closely associated with a proverb by science fiction writer Arthur Clarke that became known as Clarke's third law. Any sufficiently advanced technology is indistinguishable from magic. This problem we all have with imagined future technology. If it is far enough away from the technology we have right now, and we know and understand this technology, then we do not know its limitation and what is achievable in the future. So it sort of becomes indistinguishable from magic. The third law of deadly sins is exponentials. Many people are suffering from a severe case of exponentialism. Exponentialism was put on the map in the technology world by the very impressive 50 years run of Moore's law. The semi-log graph associated with the Moore's law have since become a visual metaphor for the technology revolution unleashed by the exponential improvement in the digital components and the processing speed and storage capacity. Moore's law has had quite a run, but likely all things based on exponential improvements, it must eventually slow down and flatten out. Over the past 30 years, the necessary ingredients to significantly increase the performance of AI systems were joined. Powerful and inexpensive computer technologies, advanced algorithms and models, and huge amounts of all kinds of data. But there is no law that says how often such events will happen. So when you see exponentialism arguments, as justification for what will happen with AI. We have to remember that not all so-called exponentials are really exponentials in the first place, and those that are can collapse suddenly. Um, when a physical limit is hit and there is no more economic impact to continue them. The fourth deadly sin is performance versus competence. We all use cues about how people perform some particular task to estimate how well they might perform some different task. For example, people hear that some robot or some AI system has performed some task. Then they generalize from that performance to competence that a person performing the same task could be expected to have. And they apply that generalization to a robot or AI system. Today's robots and AI systems are incredibly narrow in what they can do. Human-like generalizations do not apply. The fifth deadly sin is the speed of deployment. A lot of AI researchers and pundits imagine that the world is already digital, and that simply introducing new AI systems will immediately trickle down to operational changes in the field, in the supply chain, on the factory floor, or in the design of products. Nothing could be farther from the truth. Almost all innovations in robotics and AI take far longer to be widely deployed than people inside and outside the field imagine. The fifth deadly sin is so-called Hollywood scenarios. Many AI researchers and pundits ignore the fact that if we are able to eventually build super intelligent AI systems, the world will have changed significantly by then. We will not suddenly be surprised by the existence of super intelligences. They will evolve gradually and technologically over time. And our world will come to be populated by many other forms of intelligence. And we will have lots of experience already dealing with like smaller extent or higher extent of intelligent AI systems. So we are not saying that there may not be challenges, but we're saying that they will not be as sudden and unexpected that many people think. And the seventh deadly sin is so-called suitcase words. It is a term created by MIT pioneer Marvin Minsky to refer to words that can have multiple different and confusing meanings depending on the context. Learning, for example, is one such word which means something very different when applied to machine learning compared to when applied to human learning. Suitcase words mislead people about how well machines are doing at tasks that people do. That is partly because AI researchers and worse their institutional press offices are eager to claim progress in one instance of a suitcase concept. The important phrase here is an instance. That detail soon gets lost. Headlines trump the concept and warp the general understanding of where AI is and how close it is to accomplishing more. The bottom line is in all this we mentioned about these 7 deadly sins is that we have come a long way and there is still a long way to go. Businesses and individuals alike are grappling with how to use generative artificial intelligence in responsible and beneficial ways. So I did mention 2024 MIT annual conference, and the researchers shared insights and updates about their work. So if you look at this conference and do a closer look, we can see key researchers' findings, and I like to mention 5 different ones. The first one is people have complicated perceptions of AI-generated content. As generative AI is increasingly used to create content, researchers are looking to understand how this content is perceived. According to a study by MIT researcher Renee Richardson and Yunhao Zhang, humans generally express a preference for content created by humans. Yet when people were presented with examples of AI-generated and human-created content, people did not express an aversion to AI-generated content. When people were not told how content was created, they ended up preferring AI-generated content. The second key finding is data provenance is increasingly important. AI models are trained on data, and it is important to understand how that data was collected. Otherwise, it could be inappropriate for an application or which has been gathered illegally or may not include the right information. This is why a group of researchers collaborated on the Data Provenance Initiative, which audits the data sets used to train large language models. Another project, the Data Provenance Explorer, lets users select different criteria and see information about the data they might use. The third key finding is the democratization of AI has a long way to go. AI researchers used to be evenly divided between academia and industry. This is no longer the case, according to a team of researchers which found that Over the past decades, industry has gained the upper hand when it comes to computing power and access to data, making it easier for businesses to hire talent, develop AI benchmarks, and invest in research. Also, this means that industry is influencing the direction of basic AI research, raising concerns about whether future AI developments will be in the public interest. The fourth key finding is the companies managed by geeks are more agile than traditional organizations. In a new book, The Geeks Way, the Andrew McAfee looks at how geeky companies such as Netflix successfully developed new management techniques. Geek companies move faster and a lot more egalitarian. They give a great deal of autonomy and try to settle their arguments via evidence. And the fifth key finding is job loss from AI may not be as bad as some feared, at least not right away. In another study, the researchers created a new AI task automation model to more accurately predict the pace of automation. Looking significantly at computer vision, they found that technical and cost barriers could leave about 3/4 of jobs unchanged in the near term. In the short term, researchers said that businesses can perform cost-benefit analysis to determine which tasks it would make sense to automate with AI. And with this said, I am ending this presentation, and I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov. I'm the founder of the Decentralized Web project. We're building decentralized communication and advertising platform, and recently we did release a marketplace and collection of objects based NFTs and based on three-dimensional objects. So what is interesting and special about 3D objects is that there has to be special software which loads and displays this three-dimensional object. Usually, like creators of three-dimensional objects, they choose game engines, and there are two very popular choices for creators of game engines. One of them is called Unity, and the other popular game engines are used by 3D objects creators is called Unreal. But from the very beginning of our 3D NFT marketplace and collection of NFTs, we decided to build our own 3D software engine. What our 3D software engine does is it reads the file of the 3D NFT, then it opens a window on a computer screen. It loads the 3D object in this window it opened, and then it starts animating this 3D object in a way of moving it in a random fashion around the window. But in addition to like reading the file, opening a window, displaying, loading, displaying, and animating the 3D NFT, our 3D software engine does multiple additional capabilities. The first additional capability of our 3D NFTs is the capability of speaking. Our 3D NFTs can speak in one of three different voices. The 3D NFTs can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. Like a voice can be spoken either in a normal speed manner or in a fast speed manner or in a slow speed manner. So if we take, for example, a male voice and it is spoken in slow speed manner, then this voice can come as the voice of a very masculine person or the voice of an old person. If on the other hand we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a little girl or the voice of a funny person. The second additional and important capability of our 3D NFTs is the capability of voice recognition. Like if we have a 3D NFT which is animated and moving in a random fashion around a window, then we can issue our very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. We can issue following voice commands to the 3D NFT like move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go further away, zoom out, and start rotating. The next additional important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really, wow. You can ask the 3D NFT what is your name, and the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply in voice in few sentences about who they are. You can ask the 3D NFT to describe something. For example, describe Web3, or describe decentralization, or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or about decentralization or about the country called Russia. The last but not least important capability of our 3D NFTs is the capability of displaying them in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or bluish colors. Then you can come to our 3D NFT marketplace, and so probably this is the time to tell you the name and the URL of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is all together 3D NFT. Then there is dot, then there are two words, decentralized and web, and they're typed all together, decentralized web. Then there is dot, and it ends with org. Once again, the name of the website and its URL is 3dnft.decentralizedweb.org. On the top of our 3D NFT marketplace, you can see number of links, and one of these links is going to be about accessories. You can click on this link, and then you're going to see that we are offering special glasses. You can click and order one pair of these glasses, and when you receive these special glasses, you are going to see that one lens of these glasses is red, and the other lens of these glasses is blue. Then you can put these glasses on. You can request displaying of the 3D NFTs in a way of stereoscopics, and you are going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions thanks to the glasses and thanks to displaying of this 3D NFT in a way of stereoscopics. And with this said, I will be ending talking about our 3D NFTs and collection and 3D software engine. But I like to tell you a little bit about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance on which we are deploying the smart contracts for the non-fungible tokens. By having our own blockchain instance, we do not require our users to pay gas fees for deployments of the contracts and transactions of transfer of ownership from one user to another user. In addition to this, instead of having our users pay in a single crypto coins for the purchases of our 3D NFTs, we allow our users to use multiple crypto coins for buying and then receiving proceedings from sale of our 3D NFTs. The current choices of crypto coins include 4 different coins, and the choices include Solana Sol, Polygon Matic, Avalanche AVAX, and Qcoin, which is a big centralized crypto exchange. It has a coin called KCS. I did mention us having our own blockchain instance, and I like to mention that our own blockchain instance runs Ethereum software, and it is the same blockchain node software which runs on Ethereum mainnet. It runs on Binance Smart Chain, it runs on Polygon Matic, it runs on Avalanche AVAX, and it runs on many other blockchains currently in existence. But I like to mention also that in addition to buying and receiving proceedings from sale in crypto, in addition to this way, we have a second parallel and independent way of buying and selling of 3D NFTs, and it is done entirely in fiat currency. I can give an example. For example, if you're a user and you come to our 3D NFT marketplace, you click on the composite image of our first collection of 3D NFTs, then you are going to see all of the first collection, all of the objects of our first collection of 3D NFTs. Let's say you see one 3D NFT that you like, you click on this 3D NFT, then you are going to see a short video of this 3D NFT as it is moving. Then you are going to see a drop-down box. When you click on this drop-down box, you're going to see a selection of choices for payment between 4 different crypto coins and 5 different choice of paying in fiat currency. Let's say you select paying with fiat currency, you click on the button to advance next, and you're going to be presented with a screen where you can put the number of your debit or credit card. You can put the expiration date of your debit or credit card, and you can put the CVC of your debit or credit card. When you click on the button to advance next, you're going to make a payment, and what is going to happen is there is going to be a transaction and conversion from your national fiat currency to US dollars, and this payment is going to be deposited in our bank account in US dollars. What is going to happen then is there's going to be a second action and transfer of a transaction of transfer of the initial ownership from our 3D NFT marketplace to you, and now you become the first user of this first owner of this 3D NFT. Let's say you are going to play with this 3D NFT for a while, and then you can decide to put this 3D NFT for sale. You decide on the price that you are going to put for sale of our this 3D NFT, and then this 3D NFT is going to be listed for sale on our 3D NFT marketplace. Let's say there's a second user who comes to our 3D NFT marketplace. They browse through the collection of objects of our 3D NFTs, and they see and like this particular 3D NFT which you, the current user, put for sale. So then the second user is going to go through the same steps of clicking on this 3D NFT, then having this drop-down box with choices of paying with crypto or fiat currency. Let's say he decides to pay also with fiat currency, clicks on the button to advance next, he puts his debit or credit card and clicks on the button to make the payment. So what is going to happen is there's going to be a transaction and conversion from the national fiat currency of the second user, which could be different than your national fiat currency of the first user, and different than US dollars. And this payment is going to be converted to US dollars and deposited in our bank account. So we're going to follow this action with a transaction of transfer of ownership from the first user to the second user, and now the second user becomes owner of this 3D NFT. We're going to follow this action with a third action, and a transfer from our bank account and conversion from US dollars to your national fiat currency, and this transaction is going to be deposited in your bank account. And with this said, I'm ending talking about this 3D NFT marketplace project that we're working on. And I like to tell you about the second project that we're working on. This second project relates to the continuous and exponential growth of electric vehicles, especially in countries like China and some countries in Europe. This exponential growth of electric vehicles is going to present a problem with the charging of these electric vehicles, and currently the charging of these electric vehicles is handled in a way which we describe metaphorically as the gas station model. Currently we have special locations and dedicated columns which similarly to the gas station are having like pumps where internal combustion cars are coming. They load fuel in their cars from these pumps at the gas stations, and they leave. In the same way, there are specific locations dedicated to charging electric vehicles with special several columns dedicated to like electric vehicles coming, connecting the cable to the car, waiting a little while, and then leaving this location. But our prediction is the number of these similar to gas stations, electric charging stations is going to become ultimately insufficient for the exponential growth of electric vehicles. So what we are proposing, and what our project is based on, is we are assuming that there's going to be transition, and we're proposing so-called parking lot model, where the users can charge. They come to a specific parking, and they leave their car for a longer period of time, and they can connect and they can charge at the place they parked their car for a longer period of time. This location could be either the location of their living, if they live in an like apartment building, and this apartment building has ground and underground parking lot, or it can be their place of work if they working on high-rise buildings, and these high-rise buildings has ground or underground parking lot space. At these two locations, or it could be the parking lot of like it could be the parking lot of shopping shopping mart, or it could be the parking lot of like highway convenience store. So at these parking lots, the electric vehicles, they could stay for a longer period of times, and they could charge using not just fast chargers, which like contribute to the duration of the batteries of the cars, but they could use normal way of charging with level 1 or level 2 chargers. So we're currently building products in developing and building products in our project which could measure exactly the currency which has been consumed. They could detect which user wants to charge by the user presenting their debit or credit card to near field communication reader, or the user could also have a near field communication card. They could be having near field communication token, or they could be having a near field communication ring. And after identifying the user, that we could be triggering a switch which connects electricity to the cable. The user could connect the cable to their cars. They could charge their cars, and finally they could get billed for the electric power consumed at the specific parking lot, either at the place of living, or the place of work, or the place of shopping, or the place of traveling. These products that we're building on, they will be connected wirelessly, and we anticipate the problem of multiple vehicles connecting at the same time, like for example at 9 o'clock when cars are coming to work, or at midnight when, for example, the electric power utility did announce that they have cheaper rates for charging of electric consumption. So at this specific timing could be like a very sharp increase in the load of the electric power grid, and this sharp increase could lead to blackouts, because the power utility could not meet the demand. And there should be at all points of time a balance between the consumption demand and production of generation and production of electricity. This could at all times has to at all times match, and if not matching, there should be blackouts when for example days where increased load. So what we're proposing is we're building programming interface to our products, and we could provide access to the power utility to allow to get notified about the upcoming demand, and then the power utility could also um, um, specify the specific moment when a specific car could get connected to the electricity and turned on. Um, in this sense, the power utility could gradually turn on the number of cars which request powering, and they could meet the demand by increasing gradually the generation capability. With this said, I would be ending this talking about the second project that we're working on. I like to mention the name and the URL of the website. It is power.arstec.com. Power is the ordinary word for power, then there is dot, then there is Arstec, which I can abbreviate it as Alpha Romeo Sierra Tom Echo Charlie Hotel, and altogether this Arstec, then there is dot, and it ends with com. Once again, power.arstec.com. Thank you for coming, thank you for viewing. Have a nice day, have a nice evening, and goodbye.